Good morning, physics class. At least it's morning for me doing this video, so I'll say it's a good morning. First, grade 12 physics video for the year. That's part of our helpful video series for Mr. Westwood's helpful videos. Our first week here is kinematics, so kind of looking at these formulas again. Basically looking at distance, speed, velocity, acceleration, and time. Those 5 things and how they interconnect, how can we confine them, how to use these variables interchangeably, how can we algebraically change these, or how do we plug and play with them. So that's going to be, if you took grade 11 physics, you would have done this for 3-4 weeks at some point. We're going to try and kind of finish it all in 1 week, but I think we'll be fine. So let's start off with our velocity kind of formula, and honestly, I hate this formula. And the reason is because students misuse it all the time. In its simplest forms, it's very easy. Okay, distance equals time multiplied by velocity. So however fast you're going, multiply by that time, will give you the distance. And that is very true as well. If you want to find velocity, just go distance kind of divided by time, and that'll give you the velocity. Again, seems very simple, and in its simplest forms, it is very easy to use, but the problem is a lot of students misuse it, and here's an example. Here's 2 questions that look very similar, but one of these questions won't work with this formula. Okay, so question 1. If you throw a ball upwards at 20 meters per second, how far will it go in 5 seconds? So I throw a ball up, 20 meters per second. After 5 seconds, how high did it go? Okay, question 2. If a car is driving at 20 meters per second, how far will it go in 5 seconds? They sound very similar. The problem with question 1 is this velocity is not going to stay constant. Okay, it's going to change because of gravity. Same thing if I were to say I were to throw something downwards off of a building, or a lot of different things. As soon as a velocity is changing, you can never use this formula. Like time really can't change. You're going to get a set time. A distance is going to be a set distance. So those 2 are easy. But the velocity is the big thing to kind of look at in this formula if you're ever going to use it. If the velocity is absolutely exactly the same, or you can actually at least average out the velocity, then you're fine. But anytime your velocity is changing, this formula does not work. Okay, so for this one, for sure it works. Literally just go 20 times 5, you get 100 meters. This one, it's not going to go 100 meters in the air. There's a gravity that's slowing this down, so this is not going to be 100 meters. It's not going to go that high. Okay, so just want to kind of talk about this formula quickly, because yes, you can use this formula. I'm not saying you can't. I don't like it using it that particularly well, but you can use it. Just be very careful. It's got to be a constant velocity. Okay, to be fair, in our kinematics, the practice problems, there's uniform motion and then there's acceleration problems. For mostly uniform motion, you can use that formula. You just got to make sure that you're using constant velocity. Okay? All right, I also want to talk about one other thing in this video, and that is the difference between distance and velocity. So distance, not velocity, versus displacement. Displacement. I don't know if I'm going to spell this right, but that's okay. We'll be fine either way. And I want to kind of talk about 3 different scenarios, okay? So, A, if we're going around like a track, okay? Let's say we start here, and let's say this track is 200 meters. Okay, B, let's say we go up 100 meters, and then back down 50 meters. And then C, what if we do this? We go up, again 100 meters, and then sideways 50 meters. So let's talk about these 3 different scenarios when we're talking about distance and displacement. All right, you would have done this in grade 11 or even possibly grade 10, but let's talk about these again. So distance is, again, how many steps you would have traveled. So basically, if you just counted your steps of how far you traveled, that is distance. Okay, so let's say you went around this track 2 times. Okay, 1 time around is 200 meters. If you went around the track twice, that's 400 meters. Okay, so basically just add up again how far you went. Displacement is different. It is basically how far away are you from where you started. Okay, and usually there's an actual, I'm trying to think of the word right now. There's a direction. There we go, I found my word. There's a direction. So did you go north or east or west or south? Like some kind of direction is usually going to be used when we talk about displacement. So in this same exact A question, when we talk about, well, what was the displacement if this person went around the track 2 times, basically once, twice, and ended up still right there, What's their displacement? It's 0. They would have been in the exact same spot as they were when they started the race. Okay, so distance 400, displacement 0. No need for a direction there because they're actually in the exact same spot. We will use direction in this question though. All right, let's say you go 100 meters north and then 50 meters south. What's your distance? How far did you travel? How many steps did you take? Well, we'll say about 150 meters worth. Okay, you went 100 and then 50. What's your displacement? Again, how far away are you from where you started? Well, we are basically 50 meters north. Okay, if I were just to like, you went from here to here, well, if you would have just gone 50 meters north and stopped there, that's how far away you are. Okay, so that would be the displacement. You went 50 meters north. And then our last question here, all right, if I went 100 meters north and then 50 meters east, okay, what's your distance? Your distance is still 150, and there's no need for a direction. I don't care about direction when I'm talking about distance. All right, I took 150 meters, basically that's how far I traveled. For displacement, I do care about our actual direction, and for this one, you'd actually have to be able to find our hypotenuse here, okay? So you have to do your trig function, okay? So you have to go.
For you on line 200, Ms. Mann Simpson.
Interrupted by our little PA, but that's okay. All right, we're good. You'd have to go a squared plus b squared, so 100 squared plus 50 squared, square rooted. That's where you're gonna get for this. You'd also have to find that direction, which means yes, you would have to actually find this angle, okay? So to do this, again, you're gonna have an opposite or hypotenuse. So you're gonna use your tan function. Okay, TOA equals opposite over adjacent. Okay, so opposite over adjacent. Okay, and then once you do that, you're gonna have to do your negative, like tan -1. Okay, your inverse to actually find that angle, and that will be displacement. And yes, when I ask for the displacement, I am going to be expecting the actual angle there as well. Okay, so there's our kind of first video talking about two things: how to use that velocity formula as long as it's constant velocity, and then our difference between distance and displacement. All right, that's video 1. I think we got 3, 4 more for week 1. Should be all good. Thanks, class.